Albert Einstein, the mind that reshaped our understanding of the universe. His theories of special and general relativity transformed our concepts of space, time, and gravity. Yet one question continues to puzzle many people today. Why didn't the Nobel Committee recognize Einstein for the very theories that revolutionized physics? Over the years, a popular misconception has emerged that a philosophical discussion between Einstein and the French thinker Henri Bergson in 1922 somehow influenced the committee's decision. Bergson argued that while Einstein's relativity was mathematically sound, it failed to encompass the subjective experience of time, the way humans actually perceive its passage. This disagreement prompted deep reflections on what time truly is. Can equations fully capture it, or does consciousness also play a role? Indeed, it would have been significant if the committee's decision had been influenced by this confrontation between Bergson and Einstein, but the truth is quite different. The debate between the two intellectual giants became so famous that many later assumed it had swayed the Nobel Committee, yet there is no record that Bergson's critique had any real impact on the decision. The real reason was much more practical and scientific. At that time, relativity still lacked robust experimental proof. The 1919 solar eclipse provided striking evidence that starlight bent around the sun, as Einstein had predicted, but many physicists were still looking for stronger and repeatable confirmation. The Nobel Committee, adhering to its tradition of rewarding tangible and directly verifiable discoveries, remained cautious. They preferred results that could be measured, reproduced, and applied, rather than broad theoretical advancements that the scientific community was still in the process of validating. Awarding the prize for relativity would have meant challenging long-established foundations of physics, a step too bold for many at that time. In 1922, the Nobel Committee finally awarded Einstein the delayed 1921 Nobel Prize for his explanation of the photoelectric effect, a discovery that offered clear experimental proof that light could knock electrons from metal. It provided direct evidence for the emerging quantum theory and demonstrated a phenomenon that could be tested and verified in laboratories. This choice aligned perfectly with the Nobel Committee's principle of recognizing discoveries grounded in observation and measurable results. Ironically, a century later, relativity has become essential to modern science and technology. The GPS in your phone adjusts its position using Einstein's equations, which correct for two opposite effects on the satellites: fast motion that slows time and weaker gravity, the dominant one, that speeds it up. Particle accelerators like the Large Hadron Collider rely on Einstein's relativistic energy and momentum calculations to predict the high-energy collisions that occur at near-light speeds. Nuclear reactors and atomic clocks incorporate corrections from both special and general relativity to maintain accuracy. Astronomers utilize relativity to track spacecraft, observe gravitational lensing, detect black holes and gravitational waves, and measure the expansion of the universe itself. The theory, once dismissed as too abstract, now underpins every precise measurement of time, energy, and motion that keeps our modern world functioning. Ultimately, Bergson's critique did not determine Einstein's fate. It was evidence and timing that played pivotal roles. The committee's caution reflected the gradual pace of scientific acceptance, not a repudiation of Einstein's genius. This narrative reminds us of a humbling truth. Even the brightest ideas in history must sometimes wait for proof, for time, and for the world to catch up.